Hi, welcome to the Architectural Technologist Podcast. We're really fortunate to have Max Renshaw Fox with us today. Max, you and I have known each other for a long time, but please introduce yourself to our listeners.
Thanks. And yes, we have. I remember some time ago working together in an industry that required both architectural and coding sides. But if you go right back to the beginning, I started life as a teacher, actually. So that's my first degree is in developmental psych and learning theory. And that's been an interest of mine all the way through. I got into software because I wanted to make educational software. And in the long arc of it, I ended up building a practice management system for an architectural firm and therefore got to know that side of things as well. And I currently work for an organization that builds a kind of an architectural product for building windows and doors, essentially. I have a daughter who's always been interested in game development. And so she's a 3D artist nominally, but she does a bunch of other things. And it's really interested me, the technical art side of game development. So that gives you a potted overview of where I'm at.
So, when you were working in the architectural office, this is one of the reasons I wanted to interview, is that you must have noticed as the architects changed from whatever they were using, MicroStation to Revit. And that's not the only company that's done that. We interviewed someone recently who's done exactly that. But it did make me wonder whether you would see an advantage. You come from a coding background, whether you look at the architects and think, man, if only they knew some coding, they could fix some of their things.
Exactly. So there's always a tension between design and engineering, and being able to automate some of the pieces of design to make sure that it fits the kinds of things that you want, the outcomes that you want, as well as the visuals that you want, is really useful. And it was really interesting for me to watch that transition. In fact, it was MicroStation rather than AutoCAD in the particular practice that I was in, moving to Revit and a BIM system to get that interaction between them. And we had an architect there or a person who was in the process of becoming qualified, certified as an architect, who was really into coding and those sides of things. And that was really interesting to watch as well. The things that he could do, it really expanded what the architectural part of the practice could do.
I think it's really important that you expand on that a little bit for us. You know, where do you see that going? I know Vectorworks has a built-in part called Marionette, which is a visual program language, which allows you to basically connect the pieces together. And I've written a manual on how to use Marionette. But one of the things I noticed when you do that, you still have to understand basic computer coding so that you know how to put the bits together.
You do. And a lot of that doesn't necessarily come down to the code itself. In other words, the text, but it's how you assemble that. There are a good number of applications now, and the 3D modeling side of things is the same. So if you take a big game engine like Epic's Unreal Engine, they have a system of nodes, which are essentially little pieces of code that you can wire together and get transformations and transitions of things, make things snap together or make them sit apart, whatever you want to do. So it's as much as it is understanding the code itself or the text of the code itself. It's a little bit like understanding 1 + 1 is 2. Something you have to remember, but actually understanding that if you add up your checkbook and you get greater than 0 for your balance, you're doing okay. That's the same kind of concept as you need in an architectural environment. Of course, you have to learn the text because code is text. But the point is that learning the process of making something happen is the more important thing. And that's the thing that architects do as a matter of course. It's all about how can I make these pieces fit together and how can I make this environment work? The thing that really amazed me about the architects that I worked with is the depth of knowledge that they had in terms of human interaction in a space. And the kinds of things that they were designing specifically to make spaces inhabitable. And it's a similar kind of thing. You are working through those same kinds of processes, but you just happen to realize them with either text or with a series of graphic nodes linked together.
Yeah. So I think maybe we've jumped ahead because I understand exactly what you're saying. And I have had a play with these things, and I was really fortunate to get taught how to make. Vectorworks has got a built-in scripting engine called VectorScript. And I was really fortunate to be taught that. And it's a Pascal-based language.
Right.
So for me, it was easy to get. I'm not a big fan of Python because I don't understand it like I do the other one. But let's take a step back. We've got our students for 2 years for the Diploma of Architectural Technology. We've got to teach them the building code. We've got to teach them how to draw. We've got to teach them services in construction and building information modeling. Is it important enough to put coding as part of that course?
I think the short answer is yes. The slightly longer answer is that critical thinking and the process of assembling what you need is the process of code is the output. It's the process that gets to the code, in my view, that's really important. So, and take your example, for instance, you're familiar with Pascal, and that's the language that I use day to day, which some people consider to be an old language, but it works perfectly well and creates wonderful. The thing that we've got is 5.5 million lines of code, and it's all Pascal. Python, by contrast, works a different way. So there's a learning Python because the way that you put pieces of Python together are different than the way that you put the pieces of Pascal together. And that's, as an example, that's the friction that you get in terms of teaching code. So if we take your example, you're perfectly comfortable with Pascal code. You can do that. You've learned it. You're uncomfortable with Python code. And it's the same transition for any student getting used to whatever they first start coding in. So short answer, yes, it's important to code, but code is the output. It's the structure and how you get to the code that, in my view, is important.
One of the first things I had to learn when I got taught to use Pascal was stop thinking, because when I went to high school, I learned to do basic, go to, and all that sort of stuff.
Yeah.
And Pascal is that algorithmic language, and it teaches you to think in a specific way and that kind of stuff. But the beauty of learning something like that, regardless of whether you use Marionette or something else, the beauty of it is that you're no longer constrained by the limits of the software. Oh, the software doesn't do this. That's not a problem because I can do this. And you're now extending that software and making it do stuff that it couldn't do before.
And in Marionette, you have a bunch of built-in nodes that you can wire together. But one of the things that really amazed me is that you can then create your own nodes in Pascal or in Python. That's really empowering. The thought that occurred to me while you were speaking is that all of us use spreadsheets. And there's not a huge difference between a spreadsheet and your description of there are a bunch of inbuilt things that a spreadsheet can do. You can drag down and make the sum of something. But if you want to do some fancy financial or economic data, you can program a spreadsheet. And it's exactly the same thing. That the thing that you need to get to is what's the outcome that I want. So I want to sum all of these things down a spreadsheet and sum them all across. And that's a fairly simple thing to do. What do you want to achieve in your architectural design? Will the nodes that you've got existing suffice for that? Or have you got something special that you want to do and you want to create a node of your own? And therefore it's valuable for you to learn to create the code that goes into that node that you can then reuse and reuse. Because that's the beauty of code. Once you've got it, you can use it over and over and over. You don't have to draw it again and again.
It's interesting to see some of these parametric buildings where people use rules to design the building, and the design of the building comes out of the rules, not out of me understanding that this is a steel beam or this is a steel column. I'm going to have it at this angle. But no, we have a program that will then, or a series of rules really, that goes through the parameters, and then it starts to form this building based on a polygon that you may have started with. And then you say, okay, what happens if I add a side to that polygon? And then the building regenerates based on that new polygon. And by changing the polygon and adding other things, you get the building to regenerate. So it makes it very easy to create lots of iterations of your design just because you knew how to do a little bit of coding.
Exactly. And that's exactly how software development works. It's what's agile iterative development. The thing that occurs to me there too is that it's interesting. In a lot of buildings, you have an envelope that you have to build within. And so you maybe have height to boundary or something like that, and you have to work within that, but you want to do something that's expressive within that design. So parametric design would give you the ability to set that envelope that you can work within and then play with different kinds of organic structures or engineering style structures, whatever you want, that fit within that boundary. And then you'd have to move on from that and make sure that it works from an engineering perspective and so forth and so on. But as you say, it allows you to iterate. And there's a lot of evidence that the more small experiments you make, the more creative you are rather than doing one thing. So in a way, parametric design allows you to be more creative than a slower, one-off, beautiful, do-it-once system.
So your long answer was, yes, we should find somewhere to teach coding.
Absolutely.
Even if it's something small.
Yes. And even if you start with a spreadsheet, that is code. Because if you do a formula in a spreadsheet, that's exactly the essence of code.
Okay. I hadn't thought of that. I was thinking of something, making a table or coding a table, something like that.
Sorry, you keep going.
Which is really for somebody who knows how to do it would be a simple thing. But for someone who has no idea, that would be enough to get them to understand that they have to work through a structure, that you need some information before you can do something else. And you have to actually get those in a row. You can't get them out of order. Otherwise, things don't work.
Correct. And so in software development, there are two basic camps. They're not opposed to each other, but two ways of working. One is functional programming, and that's essentially what a spreadsheet and a formula is. That you want to, and part of your parametric design is that I want something that is this kind of a curve, a Bezier curve, for instance. And that's a functional side. And then you've got the other side, which is imperative programming, which is what Pascal programming is, where you make something do something. You have an external effect. So starting with functional programming, i.e. a spreadsheet, or something that can draw. So within a Vectorworks or something like that you can draw particular lines. And I see that on the Vectorworks site, they have a bunch of those things where you replicate things and you change the size of the building and it reorganizes the support structure underneath because it knows what the parameters are for how close together you want your supports or how far apart is the maximum you can have your supports. So that's one side of the thing. But the other side of the thing is, yes, I want to place 4 legs and I want to place them in the corner of my table and I want my table to be flat on the top and so forth and so on. So that's your imperative side of things that changes, has external effects, as the software industry says, that changes something outside as opposed to just calculating.
Ethan, I'm not sure if you've thought this as well, but I see we've got a problem with students who don't know how to use a formula in a spreadsheet to sum a row of columns or to sum a column, but they don't. And I don't know how we're going to get them to the point where we can teach them to write a simple code that would do something for them, to get them to make that change. I know there's a paper we could certainly do it in, which is that visual design and communication paper would be ideal for bringing in that code nature. But it does worry me, Max, that the future is coding, that there are books for 5-year-olds learning to read that are written to teach them code, to teach them how to code, that if we don't teach our students now how to code, there's going to be these kids coming through who are going to take their jobs because they know how to make software do what they want it to do.
I think so. So my daughter grew up with games in the living room. And the analogy I'm making here is that she has an automatic ability to use her thumbs on a game controller. I don't. I'm useless. I'm totally and utterly useless at it. And so what I'm saying here is that it's a familiarity thing. One of the concepts in learning things is what they call skill stacking. So you start with something simple that's familiar, and you then layer on levels of difficulty. And it's the things that games do incredibly well. You start any kind of a computer game and it's really easy, and they have an on-ramp that teaches you what you're going to do. By the time you get to that end of that game, it's chillingly difficult and you die all the time. And so what I'm suggesting here is that you probably have people who are extremely competent visually, but less competent with textually or with numbers. And it's the old story about meeting them where they are and starting with something that works for them. It's something that we used to do in a classroom. The ideal classroom of 30 kids is 30 individual learners learning at their own level. And that's practically impossible. So what you do is have groups of 5 that are at different levels, and you get the kids who are better helping the kids that need to grow. And if you're me when I'm 25 and a male teacher who doesn't spell well, you get the girls to check your spelling for you, that kind of thing. So the thing that I'm proposing here is that there must be a place that you can start for learning basic formulae in a spreadsheet. You can drag down and click on the sigma, the sum button, and it shows you that. And then you can look at the formula that creates, and that just to get the link between the visual part and the textual part. And you have to take it at a speed that people can work with. The reading recovery in schools is the same. Reading is a really difficult thing. Another little story from when I was teaching, it turns out that I'm ambidextrous. I don't have a very dominant right hand. I can write with my left hand. In fact, I can write backwards with my left hand. And parents that came into the classroom and complained to me about their kids' handwriting, I would write backwards on the blackboard with my left hand. And then I would invite them to do the same, because it would give them an understanding of the difficulty their kids were facing, because they didn't have that 20 years of practice of writing with their right hand. Or for the parents, they didn't have the 20 years of practice of writing backwards with their left hand. And so I'm suggesting that I'm of the belief that everybody can learn to code. And I'm also of the belief that it's useful for everybody to learn to code, because the nature of code is structured thinking. And that's useful for a whole lot of things in life. But you have to start small. It's the curse of knowledge thing. Once you know how to do something, it's really hard to imagine what it's like to not know. And I don't have a specific formula for where you should start, but I think that's in the interaction with the actual student.
I'm just writing some notes, Max, that I love that quote from yours. The nature of code is structured thinking, which is part of the challenge that we've got. We need to make sure our students have a form of structured thinking, because in order to produce a set of drawings, they need to have structured thinking. They need to break down that problem into little bits. They need to know which bits come first, and they need to know which bits come later, which is a lot of what coding is about. When you look at a computer program, or even Marionette, where it's just nodes that you join together, you still have to get the people to understand that they need to have, my simplest one is to get them to learn to use Marionette to create an extruded box, an extruded rectangle.
Yep.
Cool. So that's this is our aim. We want to get to this point. What do we need to get there? Oh, we need to extrude. Great. We got extrusion. That's a node. We can stick that in. What else do we need? We need the size of the rectangle. Great. We got a rectangle node. What do we need to tell the rectangle node? And so you're then starting to teach that structured thinking. You need an X and a Y. You need to have that make into a rectangle. Then you need to have an elevation, a start elevation and a top elevation. That's got to feed into the extrusion node. Bingo, there's your answer at the end.
Exactly.
Now, If you then combine that group of things with another group of extrusions or another group of nodes, you can then start to make one of those a shelf and one of those a side panel. And then you can make another side panel, and now you can replicate those shelves, and now you've got a bookcase.
Yes. And that may be five sessions that takes you to get there. But I'm sure that people are coming in with structured thinking, but structured thinking in another domain, as we call it in software. In other words, visual structured thinking for drawing, and probably have drawn all their lives. A very good friend who was a principal at Babbage, who when he retired, the first thing he did was paint, literally for 2 years solid, because he'd been so busy with work that he hadn't done the thing that he loved. He came into architecture because painting was his passion when he was a young man. And he has very structured thinking in terms of that side of things. But the same thing, he less so in terms of code. Whereas the architect that he brought through and got certified had played with code a lot. And between the two of them, they could do a lot of these things. It's familiarity more than it's ability, in my view.
So Ethan, you're still looking at the core structure. Have you got any ideas about whether this is an important thing and how we would do it?
Oh, 3 years back, I was about to hired by Stephen Tubes. That's while you're talking, while Jonathan was talking about how to build up bookshelves, and I was thinking like, okay. And at the time, what I told he was about to hire me, I said, "Hey, Stephen Tubes, do you have the material library? Because the pipes you can have a parametric thickness, the size, the length, everything. In, for example, they're using Revit at the time. You can build a material library fairly easily just by doing like, because instead of asking somebody to draw a pipe from all over and over again, instead of doing that, build a library and do it. And it's really fast. So that was now while Jonathan was talking about how to build a bookshelf. In my mind, I was thinking like, okay, what if I started like a library of pipes just for do a catalog, which has a one page, and the students to do start from there. And then we will talk about, okay, we'll do the second lessons, we'll talk about bookshelves or tables or etc. And yeah, that's really good. And I think two weeks ago, I attended BIM in New Zealand, and I met, it wasn't discussed on the podiums, but when I try to meet and talk with the people, and I also asked the same question, what should I teach to my students? And the engineers and the architects and those people in the industries, they ask, did you teach how to write apps to your students? That's really interesting questions, because our learning outcomes never talk about how to write apps, but our learning outcomes currently talk about, okay, how to build drawings, a technical, and generally it's say that, okay, to manipulate the drawings by digitals, but to do a digital drawings, etc. But it's never talk about the coding side. But it seems more and more popular. Coding is getting more and more popular nowadays. And also now I have a question. People, instead of coding by themselves, they code with AI. And what's your opinions of coding with AI?
I do that daily. It's part of my workflow now. And the thing that I find most interesting in coding with AI is that AI will always give you the average answer, because that's the way it's built. You have to provide the creative part of coding with AI. So I've just spent the last 3 days with a particular AI called Claude Sonnet version 4, and to make an existing application that we've got, which requires a lot of switches and knobs, have very few number of switches and knobs. And it's taken me, why is it 3 or 4 days? Because it's taken me that amount of time to move the AI from doing what the average .NET developer does and what is best practice on the web, and this is not a web application, to the way that I want it done. So I find it, and it's the same thing as we were discussing with parametric design. You can iterate more quickly with AI, just as the same as you can iterate more quickly with parametric design. And all of the people that I know who use it, it's knowing what your outcome is and being able to prompt the AI to give you the outcome that you want. So I don't think that it will do it for us. I think all of the best outcomes of AI are people who knew what they wanted. And I like to make the analogy with photography. When photography first existed, people thought that it would kill art. The best photographer that I know is this architect principal from Babbage, who did watercolors after he retired. You put a camera in his hands and you get beautiful photographs. You put a camera in my hands and you get average photographs. It's the person behind it that makes the difference. And the same thing in my view with AI. And I work with I am one of a number of very good engineers, software engineers. And I'm not the best software engineer by any stretch. And it's the engineering skill, or in this case, architectural skill, that I think makes the difference. So I think it's a force multiplier. And the term that I like there is that if you don't know where you're going, any road will get you there. And it's the same with AI.
Ethan and I talked about a book called The 7 Habits of Highly Effective People. Stephen Covey. And rule number 1 is start with the end in mind, I think.
Yes.
It's certainly one of the early ones. And you do need to know where you're going to get there. So I've got a couple of questions from what you've said. Does coding with AI mean that you don't have structured thinking?
Exactly the opposite. So the example that I just gave you is that I had to, but it's structured thinking at a different level. It's a little bit, so the standard saying, and this is what I've been finding over the last few days, is that it's like peer programming with a junior developer, that you need to ask and direct what you want, because there's no knowledge and direction in the AI. So yes, you have to have structured thinking, but it's a little bit different, the kind of structured thinking that you have to have. And that's the thing that I'm learning at the moment. So take it back to that analogy with spreadsheets and parametric design. You still have structured thinking as an architect, but you need a slightly different kind of structured thinking for parametric design. And you need a different structured thinking again for AI.
Because, of course, a lot of AI will give you the code you need to make a simple tool. So
simple being the operative term.
Yeah. But they're not always perfect. So I'm not doing it at the moment, but I have used ChatGPT to write vector script for me, because vector script is a Pascal based language and it knows vector script because it can research vector script. And it does do like a 95, 98% job. Sometimes it works. Sometimes there's an error message. Sometimes it calls a routine that doesn't actually exist. You've got to.
Exactly.
So it doesn't do everything for you. You still have to know what you were expecting to get out of that thing. As you say, you've got to know to guide it in the right direction.
Correct. Yeah,
so
exactly.
Coming back to our major question, is it important enough for us to teach at the diploma level for architectural technicians?
Code, you mean?
Yeah.
As opposed to AI? Yes, absolutely. Because if you don't know the code that you want out of an AI and you can't read it, you can't review it and make judgments about it. So I guess an analogy would be, if you can't read a book, then you can't make judgments about whether a novel is good or not good. And it's the same kind of a thing. As you're the gatekeeper as a human being, you're the person with the creativity. The AI doesn't have the creativity. So something that I thought about before, and maybe insert it here, is that there's a guy who's built the ability to write code to create music, British guy. And he performs live, writing code live on stage throughout Europe.
Nice.
And what got him started was actually making a little app to do this in schools. And so it's an on-ramp for kids to learn how to code. And he finds that playing is one of the great ways that people do it. Teach them how to make a tone, and then teach them how to look that tone up and down, and then how to make it louder and softer, and then how to combine some things together. And I can't remember the exact detail, but the first thing all kids want to do is make it so loud that it's distorted and it's heavy metal and things like that. And the point of that is that sometimes play and being able to experiment and just have fun is also a good thing. The great coders that I know love to code because they love the outcome, not because they love the code itself. Coming all the way back to AI, AI is a means to an end. It's not the end in itself, and it's not the creativity. You are still the creativity. You are still Stephen Covey and the 7 habits of successful people, and knowing what the end is before you start. Not necessarily before you start, because you adjust as you go, but knowing the end. Yeah, knowing what beauty is a human thing. It's not a computer thing.
So one of the things that when I was at high school, I always wanted to draw. And my art teacher told me I wasn't talented and I should just forget the whole thing. I went to university and I did the degree of architecture, and we had drawing. And of course, you say to your drawing teacher, but I've been told I'm no good. And they said, look, wait, there are talented people and then there are technical people. Drawing is a technical skill you can learn. Now, that won't make you talented and it won't make you a famous artist, but we will teach you enough to communicate your ideas to other people, which is what we want. And it's that. And the book was by, it's called Drawing on the Artist Within. And I'll find the link and I'll put it in the show notes. But that book said that drawing is a technical skill that can be taught, just like reading is a technical skill that can be taught. And I'm thinking coding is a technical skill that can be taught. Now, that won't make you write beautiful code and it won't make you make beautiful objects, but you'll still be technically competent to do something average.
Exactly. And if you have a sense of design, then you can see the output and you can make choices. So just as my friend can take a beautiful photo that's well composed, he is a good artist. First off, I can take 12 photos and choose the best one. And that's a technical skill. And the same thing happens. I can use AI to generate the code that I know that I want and get there as fast as one of the engineers I admire enormously who can sit there and type it themselves just because that's their world. But I have other skills. I have a bunch of other things that I bring to that. And they come to me when they want to know about things like product design and user interaction and those kinds of things that make it work. I go to them when I want to know low-level technical details and how do I make this thing do this other thing.
Max, I think you've answered my question. I don't know how we're going to get Ethan to put it into the curriculum, but I think it's a great idea. I've got an idea, but we won't include that in the podcast. So, Max, thank you very much for coming and sharing your knowledge with us.
You're most welcome. It's been a very enjoyable conversation. Thank you.
Ethan, I hope you enjoyed my friend Max. I think he gave us some really valuable insights. I'm really concerned about us not teaching coding.
Yeah, we talk a lot about young kids learning coding, primary school students learning coding, and we're not teaching this generation's how to code. So that means this generation will suffer. That's what I thought. And it's a really concerning. I think we need to teach coding. Thanks for really, it's an eye-opener what Max's comments are. So I really thanks him for this podcast.
Yeah, thank you again, Max. I know you're not with us at the moment, but thank you again for the time that you spent with us. Don't forget to follow us on Spotify. Don't forget to hit the notification so you get notified every time we upload a new Spotify. See you later.
Bye. All right.